So here we go with 8.6. 8.6 is a section that I find kind of fun. Obviously, you might need to have a pretty liberal definition of fun, but you get back to solving. I just find something just peaceful about solving for a variable. It's kind of like the bread and butter of algebra. So we've talked about all this other crazy stuff like simplifying and graphing, and now finally we get to like solve and get an answer and can like plug it in to check it. So that's what we're doing in 8.6. So when we're talking about solving rational equations, we're essentially talking about just solving proportions. And we're going to see that not everything initially looks like a proportion, but basically to solve a proportion, all we need to do is cross multiply. So to solve something like this, we would take 5 times 3 and set that equal to y times y plus 2. And then from there we would just simplify. So 15 equals y squared plus 2y. Oh boy, this is going to be quadratic, so we'll subtract 15. Y squared plus 2y minus 15. What multiplies to negative 15 but adds to 2? Well, it would be x plus 5 times x minus 3. And then our answers are x equals negative 5 and x equals 3. I don't know how I switched to x's in there. Should be y's, huh? So y equals 5 and y equals 3. Y equals negative 5 and y equals 3. Always go back and check, plug your answers in. If you plug in negative 5, you get 5 divided by negative 3. If you plug 3 in up here, or excuse me, if you plug negative 5 in up here, you get negative 5 over positive 3, which is the same thing. If you plug 3 in, you get 1 over 1. So all is well. But always go back and check because you want to watch out for dividing by 0. For something like this, you play the same game, 4 times 5 times x plus 2. I'm just going to jump right to 20 times x plus 2 equals 12x. So 20x plus 40 equals 12x. Subtracting 20x, 40 is equal to negative 8x. So x is negative 5. And if you were to plug in negative 5, you'd get that both of those things are the same thing. So these, yes, it's a little bit of work, but kind of look easy. It's just a fraction equal to a fraction, so we get to cross multiply and solve. Where it can be a little more difficult is where you don't have that initially, but what we're going to want is we're going to want to get to that thing. So if you have 2 over x plus 1 over 3 equals 4 over x, our goal, our mini goal before we solve is to get all of the denominators equal to the same thing. So our denominator here, our least common multiple of x and 3 is 3x. So we're going to get all of these with a denominator of 3x. So we're going to multiply this fraction by 3 over 3, so 6 over 3x, plus we're going to multiply this fraction in the middle by x over x, and then we're going to multiply the fraction on the right by 3, so 12 over 3x. And then simplifying this, you'd get 6 plus x over 3x, 3x, equals 12 over 3x. And now what's cool is since these two things have the exact same denominator, we actually don't have to cross multiply technically. We can just look at the numerators, because if you think about it, whatever we get for x, it's going to be the same on bottom for both of these. If you did cross multiply, you would just be able to divide 3x out. Or likewise, you could take the equation on the right and the equation on the left, both the left and right side right now, and technically just multiply by 3x, and then all the 3x's go away. So really all you have to focus on is the numerators. So you get this nice and easy equation, 6 plus x equals 12. So x has to equal 6. Now the one thing to be careful of there is if you haven't simplified all the way, you might get 0 in the denominator. So just double check, make sure it doesn't go in there. Nope, we're good. So 6 is your answer. If you want to pause the video and try this one out, our goal is to get common denominators and then solve. So we're going to walk through that right now. If we were to factor out 3x minus 12, that'd be 3 times x minus 4. So you can see our least common multiple of 3x minus 4 and 3x minus 12 is indeed 3x minus 12, or you could rewrite it as 3 times x minus 4, which I'm going to elect to do. So you would get 7 over 3 times x minus 4 We got to multiply top and bottom here by 3, so minus 3 over 3 times x minus 4. And then we're going to multiply this fraction by x minus 4 over x minus 4. So 2 times x minus 4 over 3 times x minus 4. And now here we would have 4 subtracting over 3 times x minus 4 equals 2 times x minus 4 times 3 times x minus 4. And now for this, you can ignore the denominators because they're the same. We'll jump right to 4 equals, I'll go ahead and distribute 2x minus 4, add 4, 8 is equal to 2x, so x is equal to 4. That looks great, but when we go back to our equation and we plug 4 in, you get a 0 here, and then you technically get a 0 here. So if that ever happens and those are your only possible answers, this is no solution. There's no value of x that you can get that gives you this fraction. We'll just try a couple more. If you have a decent understanding of this topic, feel free to just back out, but we'll just do a couple more for people who want more practice. 1 over x minus 4 plus 1 equals negative 7 over x squared plus x minus 20. I'm going to say let's factor down here first. That factors to x plus 5 times x minus 4. So our common denominator is going to be that. So we get 1 over x minus 4. Then we're going to multiply this by x plus 5 as well. Plus, when we're adding 1, we're just adding that denominator on top of itself. So x minus 4 times x minus 5, or plus 5, over itself equals negative 7 over, I'm just going to keep this written in that factored form, x plus 5 times x minus 4. Now that all of our denominators are the same, we can just focus on the numerators. So we have x plus 5 plus x minus 4 times x plus 5 equals negative 7. And now we have to solve this equation. I'm going to go ahead and FOIL in here. X plus 5 plus x squared plus x minus 20, that's the same thing as that, equals negative 7. Now let's combine like terms and set this baby equal to 0. So x squared plus 2x, and then we would have what? Minus 22 equals 0. And now for this doesn't look like something we can factor. So we would have to use the quadratic formula or menu 331. So however you want to go about that, you could also solve it by graphing. I'll go ahead and just use the quadratic formula because I don't happen to have my graphing calculator on me. So x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 22. All of that over 2 times 1. Let's get some numbers here. Negative 2 plus the square root of 4 plus 88 divided by 2 looks like 3.79. And then we'll go ahead and do the other answer. So negative 2 minus the square root of 4 plus 88 divided by 2, negative 5.79. And I'd be okay with menu 331 in that case too if you wanted to find other methods to solve that equation, whatever works for you. So their answers are not always pretty. Sometimes you get fractions, sometimes they're irrational like these. We'll do one more. So for this one, you have 2 plus 8 over x minus 5 equals x plus 5 over x squared minus 25. Now what you might notice is something's kind of jumping out at you here because if we factor out x squared minus 25, that's x plus 5 times x minus 5. So if we put that there instead, you would have an x plus 5 cancel, which is sweet. So now you have 2 plus 8 over x minus 5 equals 1 over x minus 5. So now we can rewrite this as one fraction. Multiply top and bottom by x minus 5. So 2 times x minus 5 over x minus 5 plus 8 over x minus 5 is equal to 1 over x minus 5. And now we can ignore the denominators. We get 2x minus 10 distributing plus 8 equals 1. So 2x minus 2 equals 1. So 2x is 3. So x is 3 over 2, or 1.5. But what was nice about that is we were able to eliminate that numerator, and it made our work a little easier. If you wouldn't have done that, you maybe would have had an extraneous solution. So just kind of back to that idea of just always double checking if you can. But that does wrap us up for 8.6.